Hey, welcome back to this bootcamp series. In this video, we're going to learn about cookies, sessions, and JSON Web Tokens. If you have no idea what any of those things are, that's okay. That's sort of the whole point of this video. We'll jump into the technical aspects in just a minute, but for now, sort of the big picture theme of this video is how we can have a server sort of remember or trust a visitor. Also, real quick before we get started, I just want to say that this entire bootcamp series is sponsored by me. So I have several premium video courses on web development available on Udemy, and in the description for this video, you'll find links to join them at the best possible prices. Anyways, without further ado, let's jump into the action and let's begin with cookies. Okay, now if you've been following along with this entire bootcamp series, you're at least a little bit familiar with Node and Express, so there's nothing too interesting going on here. I'm just setting up a basic server. I've got my homepage route, and I'm listening on port 3000. So if I visit localhost :3000, we see hello world. Now let's imagine I want my server to tell the visiting web browser to store a little piece of data in a cookie. Well, within this homepage route, before we send back our final response, you can just say response dot, and there's a method of cookie. So we give it two arguments, basically a key value pair. So we can make up a name for the cookie. Let's say sky, and it should have a value of blue. Right, and then you could set another cookie, response cookie. Say grass should have a value of green. Now if I save this and restart my server, now if I refresh, those two cookies are now stored in my browser. If you want to see them, you can just open up your dev tools. So you can right click, choose inspect. Instead of the elements tab, click on the application tab. Or if you're using Firefox instead of Chrome, there's a tab called storage. Anyways, on the left hand side, then we're looking for cookies, and you do need to click on your specific domain that you're currently working with. Cool, and there we see our two cookies. Now let me show you why cookies are interesting or useful. So if we go back to our server and we get rid of these lines that set or create the cookie on the browser, right? And I save that and restart my server. Now, even if I refresh, those cookies are still there, right? They are stored persistently in the browser no matter how many times I reload. And what really makes cookies useful is that the web browser by default will send along any and all cookies for the current domain in question back to the server on each and every request. So as I'm sitting here refreshing over and over again, each time I refresh, the browser is sending this data back to the server. Let me prove that to you so we can actually see this cookie data from the browser getting sent back to the server. So back in Express, we previously had this code. Now, yes, you can set cookies in Express without any extra packages, but if you want to be able to easily read incoming cookies being sent from the browser, you do want to install a package. So I'm going to stop my server and I'm going to use npm to install a package called cookie-parser. Okay, so just npm install cookie parser. Let's go ahead and import that or require it in. So const cookie parser equals require cookie parser. Okay, then I'm just going to use that piece of middleware. So I'll use it globally. So I'll just say app.use cookie parser, parentheses to actually call it. Okay, and now check this out. For this homepage route, let's log to the console any cookies that the browser is sending to us. So we could just say, just as a quick test, console.log request.cookies. So that's what this middleware is doing. It's making the cookies easily readable from request.cookies. So if I save that and restart my server, and then every time I reload the browser, back in the server's console, you'll see sky blue, grass green. And just to really prove that this is coming from the browser, you could go back into your cookies with your dev tools, and I could set sky to have a value of gray, push enter, and now when I refresh, back in the server's console, you see that value here, sky gray. So this is why cookies are so useful. You can set them once, and then the browser just automatically sends them along with each and every request. And it doesn't matter if it's a GET request, post request, any type of request, you're going to get those cookies sent to you on your server side. Now, a little bit later in the video, we'll see a few examples of interesting ways that you could use incoming cookie values. But before we get to that, I do want to show you that you can also access cookies from front-end or client-side JavaScript. So it's not just the server side. So for example, if you go into your browser's console to simulate a bit of client-side JavaScript coming from the server, you can just say document.cookie, and that's going to give you any and all cookies. Well, for this domain at least. Now, in certain situations, it's okay to allow client-side JavaScript to access cookies like this. If you're not storing anything private or security related, this is okay. So, for example, maybe just a color scheme preference or a UI layout preference. That would be fine. However, if you're storing anything even remotely private in a cookie, I think it's a good idea to disable client-side JavaScript access like this. So right now, let me show you how you can do that. Back on the server side, let me comment out this console.log line, and instead let's set those cookies again from the server side. So we can just say response.cookie. Let's just set the same values again. So a name of sky with a value of blue, only we can give it a third argument, a configuration object. And if we give it a property of HTTP only and set that to true, well, let's go ahead and save that and see what it does. So if I restart my server and go back and refresh, now when I run document.cookie to try and access it from client-side JavaScript, I can only access the grass cookie. So if we go back to application and look at all of our cookies, you can see that for the sky equals blue cookie, it has a check mark next to this HTTP only property. So when a cookie is HTTP only, the browser will still send it along with each request to the server, but it makes the cookie not accessible from client-side JavaScript, which in my opinion and the opinion of many others, this makes things a little bit more secure. Right? Because now if you have a bit of malicious, gone rogue client-side JavaScript that somehow made its way into your site's code base, it at least can't access any private cookie data. We'll talk a little bit more about that topic later in the video, but for now, let me show you a few other cookie options. So you could also say comma, give it a property or option of secure. And if you set that to true, I'm not actually going to do this, but this would make things so that the cookie will only be used on HTTPS domains. Since locally I'm running on HTTP just for quick development testing reasons, it would essentially make the cookie not be used. Now in the real world, once you've deployed your app actually up onto the web, this is a very important option to make sure you're using. Another useful option would be max age. This lets us say when the cookie should expire. Now it's measured in milliseconds, so let's do a quick experiment. If I set this to 12,000 milliseconds, that's 12 seconds. So let me save that and then restart my server. So back in the browser. Now let me remove this so the cookie's not being sent, and let me see if I can do this fast enough to show you the test. Now if I refresh, that cookie is still there, but in 12 seconds from now, if I keep refreshing, you can see, yes, the sky equals blue. It expired. So the browser knows to automatically delete it. Okay, so those milliseconds are measured from when the cookie is created. After that much time passes, the browser will know to remove the cookie. Now there are other cookie options, but I'm not going to bother going through each and every one of them. If you're interested, you can go to the Express documentation. Cookies don't have anything to do with Express in particular, right? So you could go to the official PHP documentation or whichever server-side language or library or framework you're using and find basically these same options. Okay, at this point though, let's change gears. Only before we learn how to do anything actually meaningful with cookies, I first need to show you the biggest security exploit related to cookies. Because before you even think about using cookie data for something important with real-world consequences, you need to be aware of this vulnerability. So it's something called cross-site request forgery, or CSRF for short. And I want to show you both how it works and how to protect ourselves against it. So for this next example, you can actually visit my GitHub. I've created this repo called YouTube Cookies and More. And for this next example that we're going to walk through, I'm using code from this O1 cookies folder. Okay, so off camera, I'm going to pull up those files right now. Okay, now I will point out that in that code from GitHub that I just showed you, it already has CSRF protection implemented. But in this quick example on the screen right now on my computer, I've removed the CSRF protection so I can show you how this type of attack can successfully go through, and then also how to implement the protection sort of line by line. Okay, so what we're looking at here is a very simple server setup. You've got your homepage route, and it's setting a cookie named simple test with a value of QWERTY. So you could imagine that this was some sort of sensitive value. And then the homepage has an HTML form. Let's actually just spin up the server so you can see what's going on. Okay, so if I visit localhost 3000, there's just this form, right? We could use our imagination and pretend this is for a bank website where you set an amount and then who you want to send it to. Now, before I hit submit, let me show you what's going on. So it's giving me a cookie. If we look at our dev tools, so this example created a cookie named simple test, right? And then it gave it that value of QWERTY. And again, imagine this was some sort of secret or private value that the server is then going to look for. Because if we look at what happens when you submit the HTML form, it's going to send a post request to transfer money. And if we look at that route, it's going to run an if else and saying only if the incoming cookie named simple test equals QWERTY, right? Then let the request go through, otherwise have it fail. So if I test this out and try to send this request, we see success. Now you could use your imagination and imagine that the server would only give me this cookie if I passed some sort of test, right? Like if I logged in with correct credentials or something along those lines. So now even if you commented that line out that creates the cookie and restart the server, that cookie still exists in my browser, right? So if I try another request, it works. This is great. However, we need to remember that there are malicious people in the world. So now let me show you how a CSRF attack could happen. Now actually, Google Chrome recently made a few changes that will block some of these types of attacks. So that's great. So I'm actually going to use Firefox just to show you how one of these attacks could go through. So let me put that line back that actually sets the cookie. Restart the server. Now let me try this in Firefox where a CSRF attack can still easily take place. So if I refresh in Firefox, yes, I have the cookie. So if I try to send an amount, it works. However, if I, as the user, now visit a different website in a different tab, right? So I'm using CodePen, and you can see this is bad guy site pretending to be good guy site. And you can see there's this button down here that says, click if you like puppies. Now, who wouldn't click that button, right? We all like puppies. However, before I click it, notice that it's part of a form, if we look at the code, with hidden inputs. And the form has an action that's going to try to post to my transfer money URL. Now, this bad guy domain that I'm visiting, it can't access the cookie from a different domain, right? So our cookie value is safe and secure. The vulnerability comes into play because this is going to send a request to this URL that we own on our behalf. In other words, the bad guy site doesn't even need to know the value of our secret cookie in order to take advantage of us. Right? So the bad guy site is going to send a request to our domain, and then you can see there's hidden inputs where they're going to send $99 million billion to bad guy. So if I click this button, success. Uh-oh, it went through. So this is a security nightmare. The reason this type of attack works is it's taking advantage of the very nature of cookies, right? Cookies are automatically sent along to each and every request made to that domain. So in order to stop this type of attack from working, we need to think about what badguysite.com can and can't access. So really, it can't access anything on our actual website, right? It can't access the HTML, the CSS. So the easiest way around this, if we go back to this screen, is to just have some sort of value in the actual HTML or DOM, right? Because badguysite.com will not be able to access that. They're just taking advantage of the fact that cookies get sent along automatically. So we can have a value in our HTML, and then only if that value is a match or makes sense, only then do we let the request go through. Now, to implement something like that in Express, there's a great package called CSRF. So right now, off camera, let me pull up this code from the O1 cookies folder because this shows you how to implement CSRF protection. Okay, so here's the code with the protection implemented. So I'm using a package from NPM called CSRF. And then this is just boilerplate configuration for the package. You could find that on the package's documentation page. But essentially, this is now a piece of middleware that I can use for either specific routes, or I could use it globally for all of my routes. But what it does is if you use it on a GET request, right, a page where maybe you'd have an HTML form, what it does is it makes a token available to you. So you can see in this HTML form that the user can submit, I have a hidden field with a specific name of _CSRF. And it has a value, and then this is what the middleware is making possible. It's going to generate a token value, okay? And now when you submit this form, right, the transfer money post request, I'm using that as a piece of middleware. And the package will check for this token value with this _CSRF name. And if it doesn't like the value, or if the value is blank, it's going to throw an error, right? So this will just not go through at all. Instead, we're catching the error down here. We're saying if the error equals ebad CSRF token. So yeah, let's take it for a test drive. So if I restart my server, back in Firefox, if I refresh and try this, so it still goes through. However, back in CodePen, if I try the attack again, let me just add a little bit of code to refresh the CodePen view. Click here if you like puppies. CSRF attack detected. Cool, so it fails because there's no way for badguy.com to actually access the DOM or the HTML value, that hidden input with the CSRF token. So that's just a quick example of how you can use cookies without being open to that really popular CSRF attack. At this point, let's change gears because now I want to show you the most common way that cookies are actually used in a meaningful way in the real world. And this is something called sessions. So back on my GitHub repo, you can see this O2 folder, O2 sessions. This is the code that I'm going to be walking through next. So off camera, let me pull that up. Okay, and before we walk through this code, let's actually just see what it's doing. So let me start up the server. And if we go refresh localhost. Okay, so we see it's greeting us, but it's considering our name to be guest. However, if we fill out this form and say that our name is Brad, submit, it says thank you, you can go back home, and now it remembers my name, and no matter how many times I refresh, it remembers my name. Now this is in Google Chrome, but if I jump to a totally different browser with different cookies, so here's Firefox, I can do the same thing, right? So I can say my name is Barks a lot. Submit. Click to go back home, and it remembers me. Now, you might be thinking, well, what's the difference? We just learned about cookies, so aren't you just storing the name in a cookie? No, that's not what's going on. So if you actually look at the cookies for this current domain, you can delete the simple test cookie that's from the previous example. But you'll notice there's a cookie named connect.sid. SID stands for session ID. And the value, here's what's important. If you look at the value, it's a really long value, so I had to copy and paste it so you could see how long it is. But this is a session ID. What in the world does that mean? Well, what's going on is our browser in the cookie value, it's not storing the value of Barks a lot or back in Chrome of my name. Instead, the server is storing that actual value in memory or in a database. We'll talk about that in just a bit. But the server is responsible for storing the session data. This session ID as a cookie, right, that's going to get sent along from the browser to the server on each request. And really that's just letting the server know which individual unique session that you are. Right? So it's sort of creating this persistent, ongoing back and forth between the browser and server that otherwise wouldn't exist with just the HTTP protocol in general. In other words, it's letting the server keep track that I'm the same person that I was just a moment ago when I input my name. you might be wondering, well, what's the point of this? Why would you bother keeping that data or that value on the server side? Why wouldn't you just keep it in a cookie on the client side? Well, it's because now we can trust these values, right? If we're the ones actually storing them on the server side, we have control over them. We can validate them, we can sanitize them, we can use these values in our application, right? Because we can't actually trust the value in a cookie, because you saw how easy it is for a user to go in here and manipulate their cookie, right? So if I change my Connect ID and then refresh, the server doesn't recognize me, right? Now I'm back to guest. That's why we want the data that we would actually use to live on the server side, right? Because instead, if we were storing it on the client side, someone could just create a cookie named bank balance and then set their value to 99 trillion. So if I refresh again and fill out my name, submit, it's going to give me a new cookie. If I go back home and refresh, you might need to click off of that cookie screen in your DevTools and then click back onto it to see the latest data. But now you can see again, my connect.sid has a new value. Cool, let's take a look at the actual code of how this is working on our server side. So you can see I'm using this package from NPM called Express Session, and I'm using it as a piece of middleware here globally for all of my routes. We're just giving it a configuration object. Nothing too interesting going on here. This is just a boilerplate that you can read about in the Express Session documentation. But now with this middleware in place, let me show you the part that's actually interesting. So if we go down to our homepage route, I'm saying, first of all, I'm creating a variable of name and setting it to guest. But then I'm saying, if there is session data for the current visitor, then set that variable to whatever the session value is. Otherwise, just let it remain guest. Okay, now if someone does fill out that form and submit the form, then that's going to run our post route for choose name. So down here, post request for choose name. This is the interesting part. So this, thanks to that middleware of Express Session, this is how you can store data for this unique session, right? It adds a session object onto our request object. And then this is just me pulling in the value of whatever the user typed in. Now I do want to point out there's nothing special about this word of user. I made that up. So you can set any sort of data you want. So you have this request.session object, and now you're free to store whatever you want to store on it. So we could say request.session.fave color equals purple. Or instead of hard coding this value, you could imagine you pulled that from a form field or from your database or anything, right? The possibilities are endless. So you can just say request.session.whatever. So I just want to make that clear so you don't think that you need to always use .user. That was just an example. Really, you just have this object and you're free to store whatever you want to store in it. Okay, and then back up in the form that we looked at just a moment ago, that's where we're pulling that stored name from request.session. Okay, and then if someone clicks the log out button, that's just going to send a post request to /logout. We have a route down here. That's just going to call session has a method called destroy. That's all that's going on. Now, this is all well and good, but if sessions are still confusing and it's not making sense to you in terms of how the server is really holding on to this data, that's okay. In just a minute, we're going to look at another example of sessions where you can actually visualize and see the data that the server is storing. I think being able to see the session ID in a MongoDB database will make it crystal clear what's going on and how this actually works. So I do want to point out that this default way that we're using sessions in this code example, this is only designed for testing and local development. You would never use Express Session like this on a real server. And I'll show you why. Because if I stop this server, so Control-C and then start it up again, it loses track as soon as I refresh. Notice it doesn't remember me. It lost all of that session data that it was storing in memory. So in the real world, when you're not just running locally and developing, you would want your session data to have some sort of persistence. So in case your server crashes and you need to reboot, you don't lose all of that session data. So the next example that we're going to talk about, and I think this next example will also make sessions a lot clearer, is this O3 sessions with DB folder. By the end of this example, I think sessions will be crystal clear for you. So off camera, let me open up this code. Okay, now this code is exactly the same with one exception. So now instead of storing the session data in memory, we're storing the session data in a MongoDB database. Now you don't need to follow along, but if you do want to follow along, you could just run npm install in this folder. And then you do also need to create a file named .env and have a variable named uppercase connection string. And then set that to a working MongoDB connection string. If that doesn't make any sense, that's okay, but in our previous video on this channel, we learned all about MongoDB and connection strings. Anyways, let's take this for a test drive. So let me start up the server. Everything is exactly the same other than the fact that our session data is now using a store that's a database. Let me show you why this is cool. So let's start up the server. Do be aware that instead of index or app, we do want to call db.js. That's the file. The db.js file is what we actually want to start to begin the server. Okay, so now back in Chrome, if I visit localhost 3000, I can set my name to PersLoud. Go back home. Cool. Only now our Node.js server is not storing that data of PersLoud. Instead, our database is. So here I am in MongoDB. You can see I have a database called YouTube Session Connect, and it has one collection named Sessions. So I didn't have to name this collection. The NPM packages we're using of Connect Mongo and Express Session, they came up with that name. But if I look inside that collection, it has one document or one item for that session I just created where I said my name was PersLoud. So you can see it has an ID, and now yours will be different because this is randomly generated, but it's VURWIV, and this corresponds with the session ID that my cookie is holding on to. So if you go into your dev tools, my cookie for connect.sid, if we look at its value, now this beginning S%3A, that's always going to be there, but then directly following that, you can see that this matches the session ID in the database. So essentially what's going on is our cookie is being sent on every request from the browser to the server. The server receives this and it says, hey, that's a match, right? That is a valid session ID that I have in my session store. So I can trust that you are who you just said you were, right? If someone doesn't have this exact value in their cookie, if it's off by even one character, then the server won't trust you. But if it is a match, it's going to look you up in the session store, and then it can use this session data. Now, it's sort of hard to scroll through this and see all of the text, so let me copy this into a text file so we can easily read it. But you can see towards the end here, we have user should have a value of PersLoud. In other words, this data is being stored on the server side or in our database. Hopefully this is starting to make sense. Right? The browser just sends along a cookie session ID. If it's a match, then we can use this data. We can trust this data on the server side. So just as another quick example, if we tried in Firefox, right? If I say my name is Dog, submit, go back home. Yes, it remembers my name, but more importantly, if I click Find to show all of the new entries in the database for this collection, now there are 2. And I won't bore you, but obviously my session ID in the cookie in Firefox is a match for this ID. And if we look at this data that it's storing, right, let me paste this in. Now you can see the user set to Dog. Okay, so this concludes our section on sessions. Now I want to switch gears and talk about something completely different. Something that is radically different from sessions, and it's called JSON Web Tokens. This could probably be another topic for another video, but I really want this video to give you a good idea of how authentication and trusting requests works. And JSON Web Tokens is an incredibly popular technology, so I wanted to include it here. So in this same GitHub repo, you'll see that folder number 04 is JWT, JSON Web Token, /localStorage. What in the world does any of that mean? Well, let's find out right now. So off camera, let me open up this code. Okay, so here's the code, and right away I want to let you know that this is 180 degrees different from sessions. So this is an entirely new topic. However, it's still sort of solving that same problem of how can we trust requests and how can we sort of remember that someone is who they were just 10 seconds ago, right? Just basically identifying and trusting requests. Now, before we actually dig through this code and really talk about what's going on, let's just take it for a test drive. Only instead of using our browser, I'm actually going to use Postman. Because this approach of JSON Web Tokens, this doesn't even need a web browser to work. This is very platform agnostic. So let me go ahead and start up the server. So just node index. Now I will let you know that we basically just have two routes. So you can make a post request to /login. And you could imagine that you actually hook this up to a database with usernames and hashed password values. But for now, I've just hard-coded it to, if you have a username of John Doe and a password of Cordy, it considers that a successful login. Okay, for now, that's really all we need to know about the login route. And then, after that, if you successfully log in, you should be able to visit or make a post request to /topsecret. And then only if you're logged in should you see this secret message of hello, and then it says your name and tells you your favorite color. Otherwise, if you visit /topsecret, it should just say failure. So let's try out this login route. So in Postman, make a new request, set it to a post request to just HTTP localhost 3000 /login. Okay, let's send over a little bit of JSON with a username and password. So I'm going to click on headers, set content type to have a value of application /JSON. And then we can go into the body tab, click raw, and just give it a JSON object, right? So curly brackets, say quotes, username should be John Doe, comma, password should be Corty. Well, actually, first of all, let me get this wrong on purpose. So if I send that, you can see it responds back with failure. But if I get it right, so just password of Cordy, it says status success. But more importantly, it gives me a token now. Let me zoom out a little bit. So you can see the token is quite long, but now I can use this token for any future request where I want the server to be able to trust me. Let me show you how this works. So go ahead and copy that into your clipboard if you're following along. Okay, and now let's try to send a post request to this top secret URL. So let's just change the URL from /login to /topsecret. Okay, let's actually get it wrong on purpose. So in this raw data, if I just empty that out and don't send along any sort of a payload and click send, we see failure. However, let me zoom back in so you can actually read this. If I include curly brackets for a JSON object and say that it should have a property of token, and I give that a value quotes, and then just paste in my clipboard, right, that really long token value, click send, we see status success, and it says message, hello John Doe, your favorite color is green, and we can tell you the secret info that the sky is blue. However, if I got this token wrong by even one character, right? Like if I change this last letter from a K to a Z, click send, it says status failure, right? So you have to have that exact cryptographically secure token in order for it to trust you. At this point though, let me put that back. Let me explain how this is working. So let's look at the code. Actually, first I want to make it clear that when you're using JSON Web Tokens, the server is not storing any data whatsoever. The data and values themselves are actually included in that really long token value. So this means the server doesn't need to store that data in memory. It doesn't need to store it in a database. The client side is actually indirectly storing those values in the token. Now you might think, isn't that incredibly insecure to ever trust client-side data like that? And the answer is, well, normally it is, but with JSON Web Tokens, this is supposed to be at least cryptographically secure. So let's take a look. In terms of our login route, if you correctly log in with John Doe and a password of Cordy, look what we're giving back. We're saying status success, but then we're also saying token should be, and then we're using the really popular JSON Web Token package from NPM to sign or generate that really long token value. So there's this method of sign, you give it an object of what you want to actually live in that token. You could have another property in here of fave food, and it could have a value of pizza. But the idea is when you use the sign method, you just give it an object. You can store whatever you want to store. Okay, then you also give it a second argument, which is your JWT secret. Now, you would want to set this to something very secure. You can see I've set it to this string of text. You just want to choose something that's difficult or almost impossible to guess. Okay, but altogether, that's going to generate that token value. And then it's up to the client-side code to sort of store or hold on to that token value. And then when someone visits our top secret route, let's take a look at what's going on. So you can see we're using a JSON Web Token method called verify. So in that case, we're just giving it the token value that a user is passing along. We don't know if this is valid or not, if it's a correct token or not. However, we can give it a callback function, and then it will throw an error if that is not a real valid token. If it is a real token, it's also going to give us the decoded object that was stored in the token. So then we can access that, right? So I'm saying if else for if there's an error. If there's not an error, well, then decoded is going to be that object that we stored in the token. So that's how we're able to say hello, and then it pulls in the name that we set up here, and it says your favorite color is whatever we set up here. Cool. Now, like I said before, this JSON Web Token approach can be very platform agnostic. So we already saw it in action in Postman, and really any platform, like a native iOS or Android app, they can all make HTTP requests, right? And they're all capable of storing on or saving a value like this token. So you can use your imagination that this JSON Web Token approach can be useful in so many different scenarios. However, this is not a bootcamp series on just computer programming in general. Really, this is about web development. So now I want to show you how you would use this token approach like this for a website or web application. So getting back to our code, you'll notice there is a public folder, and it has a file called frontend.js. So right now, let's see this in action. So if you still have this server up and running in your command line, you can just visit localhost 3000 in your browser. Okay, and then that front end or client-side JavaScript file we just looked at, that's powering this user interface, right? So if we get this login wrong on purpose, we see sorry, try again. However, if I get it correct, well, I didn't actually program in a success message, so it doesn't actually do anything. But now I can click this Get Secret Info button, and you see that exact same message from that /top secret endpoint. So essentially, when I successfully logged in, the browser stored that token in the browser's local storage. Local storage is really an alternative to cookies. It's another way that the browser can persistently store a piece of data. And then when I clicked Get Secret Info, it sent that token along with the request. Really quick, let me show you where you can see your local storage in a browser. So in your DevTools, again in Chrome it's under Application, in Firefox it'll be under Storage, but instead of cookies, you can just click on Local Storage for your domain in question. And you can just see I've created a key named our token, and the value is the actual token itself. So then if we look at the client-side JavaScript, when we try to fetch that top secret info, I'm just using Axios to make a request, a post request, and I'm giving it a property of token, and I'm pulling that value from local storage. So local storage in front-end JavaScript is simple to use. It really just has a few methods you need to remember. There's getItem to retrieve, and then up here I used localStorage.setItem. That's it. So big picture, this is an example of how you would use client-side JavaScript in a web browser to take advantage of JSON Web Tokens. The reason this approach is neat is it's still very platform agnostic. You could have other platforms like iOS, Windows, Mac, Android. They could all take advantage of these same endpoints on our server side. So that's the plus side of using local storage. Now let's talk about the downside of using local storage. Now, I should have mentioned this a moment ago, but the key difference between cookies and local storage is that cookies are sent automatically from the browser to the server on every request. Local storage does not do that. Local storage on its own doesn't do anything automatically. It really just sits there, and it's up to you with your client-side JavaScript to make something happen. What does this mean? Well, remember, for security reasons before, we were able to say that a cookie should be HTTP only, meaning client-side JavaScript cannot access the cookie. Whereas with local storage, that's not an option. The whole point of local storage is that JavaScript can access it. Really, that's all it can do. That's the whole reason it exists. The browser's never going to automatically do anything with your local storage. So let me circle back to the actual topic at hand of why perhaps using JSON Web Tokens with local storage like this is a bad idea. Let's talk about worst case scenarios from a security perspective. So what I'm getting at is, imagine somehow, some way, malicious client-side JavaScript made its way into your web app. This could happen in several different ways. Perhaps you're running a social media website and you forget to sanitize user input, and a malicious user stores JavaScript in a field, and then when someone else visits your page, it runs the JavaScript. Or, even if you're perfectly sanitizing and escaping all values, what if, for example, Google Analytics or some other third-party package you're using in your client-side JavaScript, what if that was compromised, right? And it wasn't really your fault, but it was compromised nonetheless. Well, let's look at that worst-case scenario and compare local storage to cookies. Let's start with local storage. So if there was malicious client-side JavaScript running on my site, all it would have to do is just say localStorage.getItem, our token. That's it. The bad guys now have our token, and they can use this on any computer or device in the world to mimic us, to make requests on our behalf. They can do absolutely anything they want with this token until this token expires. Now, if you contrast this with if we were using cookies, an HTTP only cookie, well, yes, someone could write whatever JavaScript they want to make requests on our behalf using our cookie, and those requests would go through. However, it's relying upon the innocent person having this tab open. As soon as the innocent person closes that browser tab, the bad guys can no longer make requests on your behalf, right? Whereas in the previous example, once they have your token, they can use that token on any device they want for as long as it is not expired. So in both of those situations, it's horrible, right? That's a worst possible case scenario that somehow malicious JavaScript was running on your front end. How likely that is to happen is not for me to say, but I just wanted to bring that up to you because as you go around on the internet, you're going to hear different arguments for and against these different ways of using JSON Web Tokens. And it's really not for me to say dogmatically, which approach you should take. I'm just trying to make you aware of the pros and cons of all the different approaches. So, having said that, for the final example in this video, back in the same GitHub repo, you'll notice there's this folder called 05 JWT cookies. Now, I'm not even going to walk through the code on this folder with you. I'm including it here, though, because I encourage you to do a little bit of extra credit and try it yourself. Essentially, I just included this example because I don't want you to associate cookies with sessions and JWT with local storage. You could definitely mix and match. And that's exactly what I'm doing in this example. I'm using HTTP-only cookies to store the JSON Web Token, and it works just fine. However, what is the trade-off with this approach? Well, my endpoints are now not super platform agnostic, right? Since I'm relying on cookies, they really only work for a web browser. So it would not work with necessarily an iOS or Android native app. Big picture, and this is just my own subjective opinion, so take it with a grain of salt, I would use this approach. Well, maybe not even necessarily local storage. I just mean JWT. I would use this for an API, right? Endpoints that you want to be very platform agnostic. And I maybe wouldn't even use the JSON Web Tokens for my web browser app. I would only use them for my API. And then for the actual user interface web browser experience, I would use this approach with sessions. Sessions make it easier to handle the edge case scenarios where you need to maybe temporarily ban someone for 20 minutes. Or for example, maybe when they log out, you want to give your user an option to log out of all other logged in devices. Now, there are ways that you can get creative and implement those sorts of things with JSON Web Tokens, but it's not as easy to do as it is with sessions. That's just me. I'm going to leave it there because you could ramble about this topic for hours. If you search Google or Stack Overflow on this topic, you're going to see all sorts of different opinions and best practices. It can be overwhelming and confusing, as I'm sure parts of this video were that way as well. However, hopefully this gives you sort of a big picture mental map of what's out there and how it works. Okay, but that is going to bring the technical aspect of this video to a close. Hey, congrats on making it to the end of this video. Now let's talk about where we go next from here. Obviously, there's an infinite number of technical topics we could continue to cover, but really we've covered the main 5 topics that I wanted to cover with you in this bootcamp series. If we look at the chapter graphic, remember I wanted to talk about design, programming, servers, databases, and user authentication. Now I know we only spent a little bit of time on each of these topics, but it's really up to you to continue to specialize and learn whichever ones you're most interested in. However, where do we go from here? Well, in the next video, I want to give you sort of a big picture, what I recommend as a few next steps you can take. So both technical and non-technical things that I think will help you on your journey. Really, I just want to share some big picture advice that if I had a time machine, I would share with myself when I was just getting started with a career in web development. As always, if you're enjoying this bootcamp series, I'd appreciate it if you could share the link with your friends and family. Take care, and I'll see you in the next one.